Hello friends, my name is Rahul. So now we'll discuss about concept 3, which is property, state, continuum and equilibrium of a thermodynamic system. Before that, I would like you to go through my previous videos, which is concept 1, macroscopic and microscopic properties, and concept 2 about system surrounding and boundaries. These two topic understanding is very much required to understand this concept 3. So this is the highlight. First we'll understand the concept and then we will have notes about it and we'll discuss the problem. So what is the property? So we discuss about the system, and to describe the system we should know the property of the system. Like if I talk about in very layman language, like if we know about any human being or a person, so we tell about him by his name to describe about him. If we don't know the name to third person, so we may tell about whether he's a tall or short guy, fat or thin, black or white, just to understanding ki how he looks, to describe about him. So similarly in case of the system also, we have to describe the system about it by its properties. So once we tell its properties, we understand, oh yeah, this is the system which I am talking about. So we will discuss about the state of the system also, in what state it is, and also we will discuss about the continuum. Continuum is quite related with macroscopic and microscopic, and also what defines that system is in equilibrium condition, because in thermodynamics we discuss about the whenever we discuss about any system, we assume that system is in equilibrium conditions. If a system is not equilibrium conditions, means there is unbalanced forces in the system, then system will move from one state to another state, and the movement of one state to another state is not the scope of the thermodynamics. It is mostly scope of the heat transfer or kinematics. So here mostly we discuss the systems which are in equilibrium. Yeah, so we'll go in detail now and we'll get some notes also. So what is the property of a system? So like we discuss about the macroscopic properties. Macroscopic means we are dealing system with a larger perspective, and the system properties are considered as a point properties. We are not going at the molecular level and we are not defining the properties of the molecules in the system. Rather we are defining the overall system with a single property, like the system has a temperature of 50 degree or pressure of 10 bar, anything, but we are not defining multiple pressure for a single system at a given time, right? So these are the properties we usually use to define the system. Like we use weight for a person to define whether it's a tall, short, or black, white, or anything, color, weight, or about him. So here similarly for the system we have the mass, volume, energy, pressure and temperature. These are the main characteristics which defines the system. However, there are some other properties is also there which can be used, but usually we are using these properties. So other properties are viscosity, thermal conductivity, modulus of elasticity, thermal expansion coefficient, electric resistivity. Even velocity and elevation also considered as a property of the system and can be used to define the system. There are so many properties of the system, so we broadly categorize them into two types of properties. One is intensive and one is extensive. Intensive means the independent of mass, size or extent of the system. Here we should remember that in most of the textbooks it is written that intensive properties are independent of mass, but uh, along with they are also independent of size or extent of the system. Here to remember, in just to remember, we can take this in as a independent, so independent of mass, where extensive properties are the dependent on mass, size or extent of the system. Since they are intensive properties are not dependent on mass, so that's why they are not additive. If I double the mass or I double the volume, the intensive property will remain same. Like temperature, if I increase the volume of the system, the temperature will be same. Similarly pressure, we will just understand by with this diagram. So here this is a system where the mass, volume, T in like M, P, T, P and rho, these are the property of the system. If I consider this system in two halves, then mass will become half in both the sides, volume will also become half, this is a half volume, and this is a half volume. And since volume has a half, so mass has also become half, but temperature will be same, pressure will be same, and density will not change in both the sides. So that's why intensive properties are not additive, because temperatures will not become 2T, or if we do half half, it will not become T by 2 and T by 2, it will remain T. Where extensive properties are dependent on mass and they are additive in nature, so like mass, volume and energy. So here mass are additive in nature, so if you club these both the volumes, mass will become M, volume will become V. So that's why mass and volume both are in additive in nature and they are extensive property. Whereas the temperature, pressure, density are in intensive is nature. If you cut the volume in further more parts like 1, 2, 3 and 4, then temperature, pressure will, all these parts will be same, but mass will become M by 4 and V by 4 is the volume. So similarly, these extensive properties are additive in nature, but where intensive properties are independent of mass. So we'll solve a couple of problems over this. This is the problem. Is the weight of a system is extensive or intensive property? So weight is basically m into g. So mass is there. If we double the mass, the weight will also become double. So it's in extensive in nature. It's not independent of mass. The weight is dependent on mass. So extensive will be the answer for this. Another, that list consisting only of the intensive property is, so only intensive property means independent of mass. So these are the options. I would like you to solve this problem, and we can discuss this problem in comment section if you have any problem, and you can mention your answer also in comment section. Now next property is the continuum. Continuum property is very similar to the macroscopic and microscopic property we discussed. So continuum is macroscopic, means we are dealing the system with a larger perspective. We are saying that when the system, there is a distribution of the matter or mass within the system, they do not have any empty space, means there is no jump in the property. If any system is there, its property is same throughout the system. Means temperature, like there are no local hot spots, like temperature somewhere is 40 degrees, somewhere is 20 degree. The temperature is uniform throughout the system, pressure is uniform throughout the system. There is a homogeneity within the system. There is no holes. No holes means there are no empty spaces in the system. And this continuum help us to idealize all the properties as a point function. So we can treat it as a point function. We can say the system temperature is, let's say, 32 degree. We need not to say that one corner it has 32, another corner it is 45. So this will create a complexity in the system. But the continuum also, when the system can be called as a continuum, so it is not always like system is as a continuum. So there is a condition which it has to fulfill, is this the space between the molecules of the system, inside the system, or the matter space or the molecules space should be quite smaller than the system dimension. So means the other way of saying this, the size of the system should be quite large compared to the space between the molecules. So how we'll define the space between the molecules is the mean free path of the molecules. So this is used quite frequently in statistical thermodynamics. So mean free path of the molecule should be quite smaller than the system characteristics dimension. So if we are discussing about a circular, then sorry, cylindrical system or spherical, then we talk diameter as a characteristics length of the system. If it is a square, then one length can be considered as a characteristic length of the system. So this length should be quite large than the mean free path of the molecules. So there are a lot of molecules in the system, they have some mean free path between them. So this should be quite small than the characteristics length. So some of the cases these dimensions become quite significant, like when we are discussing rarefied gas flow theory, which is not the part of our syllabus, so we'll not go in detail. Again, this is also not part, but when we are at the high altitude or high elevations, like in kilometers, like 100 kilometer, then there is a very low pressure, and the pressure is always created by the molecules. So if there are less number of molecules, their mean free path will be quite big. So to consider their system as a continuum, we need a very large dimension of the system. So these system dimensions are comparative to the elevation also, and what kind of molecules we are dealing with. All the molecules have different mean free path, and because of their different mean free path, the system continuum definition also at par with this to consider as a point properties. Now next concept is the state of the system. So like we discussed, to define any person, we tell about his characteristics, like whether he is tall, short, and other characteristics. Similarly, to define a system, we should to tell about his characteristics, like temperature is 20 degree, volume is 1.5 meter cube. So okay, I understand that, okay, this is the system we are talking about. Similarly, if temperature is 20 degree and 2.5, then system state will change. This is state 1 and state 2. So here one question comes, how many minimum characteristics I require to define a system? Suppose if I only tell about temperature, both temperatures are same here. So you will understand that, okay, both the states are same, but it's not true because volumes are different. So in this case, we need minimum two properties to define the system, and other properties we can find out through different thermodynamic relations like PV equal to nRT, and there are various other relations which help us to find out all other properties of the system. But the minimum number of required characteristics may or property may change. In case of two-phase flow it is different, and in this case it is different. So this will discuss in detail in the upcoming lectures. So like if we go for a electric battery, so we need to have some specification, like what is the voltage or current, or either any of two, V, because V equal to IR. So we need any of the two properties to understand what kind of battery is this. So always we need some properties to define a state of the system. So there should be a minimum number of properties from which all other properties can be calculated or measured. Next is the concept of equilibrium. So in thermodynamics, however its name is thermodynamics, means it is in dynamic condition, but in true sense we always discuss about the system which are in equilibrium. If there is any unbalanced force or there is any unbalanced temperature difference, then the system will be in a dynamic condition, and the unbalanced temperatures are discussed in heat transfer, not in thermodynamics. So in true sense, whenever we are discussing any thermodynamic system, we are it means that it is in equilibrium condition. So what is the equilibrium? Defines as there is no unbalanced potential forces within the system. So the system will be called in equilibrium state if unchanged value, as long as the external conditions are unchanged. So if external conditions remain same, the system will also be in the similar conditions, because there is equilibrium is maintained. And when we'll say that key system is in equilibrium, when it fulfills three conditions. One is mechanical equilibrium, means there is no unbalanced mechanical forces. So we can understand through this figure which shows the mechanical equilibrium. Here you can say that this is the mass which is kept on the piston, mass M. Let neglect the piston mass, or you can include the piston mass with this mass as a M. And this is the outside pressure which is also working in the direction of this mg mass. M into G is working downward. This P naught into A is also putting pressure on this piston, and the pressure inside the system is acting against this both of the forces. So mg is the force downward, P naught A outside pressure and area is the downward force, and P into A is the upward force. So if it is in equilibrium, that will be maintained. So this is called the mechanical equilibrium. There is no unbalanced forces. Now the thermal equilibrium. Thermal equilibrium means, like we discussed, there are no local hot spots or cold spots which is causing the thermal mismatch or temperature mismatch. Like here 32 degrees there, so this is 32 degree everywhere, and ideally it is on thermal equilibrium. Similarly, it should be on chemical equilibrium also. So chemical equilibrium means the rate of forward reaction is equal to rate of reverse reaction, and this is the sign for the chemical equilibrium. If it is not in chemical equilibrium, like we know, most of the chemical, in fact all the chemical reactions either uses absorb the energy or release the energy. If this is the case, then it may create the thermal unequilibrium in the system because of the chemical unequilibrium, and it may lead also mechanical unequilibrium conditions, because it may lead to increase in pressure and other things. So it is important to have the system in chemical equilibrium, thermal equilibrium and mechanical equilibrium, then only it will be called as a thermodynamic equilibrium. Thermodynamic equilibrium is satisfied by this thermal equilibrium. It should not be misguided with the thermal equilibrium only is will lead to the thermodynamic equilibrium. There are the three equilibrium conditions has to be satisfied. So that's all about this lecture. You can if any problem is there, we can discuss in below comment section. Thank you.